Alright, so let's get started. What we're going to be doing now is very similar to what we did before. So here's the problems that you're going to do. There's only a few of them, but they will take a little bit longer. We'll do the first three together. Just to compare what we have done with what we're going to be doing, let's take a look at what we just completed. And most of the, or all the problems that we did yesterday were only at most a cubic function, so a third degree at most, and none of them had a coefficient, a leading coefficient here other than 1. So when we did the rational root theorem, it was really only the factors of whatever the constant was. We didn't really have to do a lot of dividing. So for today, you're going to see not only do we have above a third degree polynomial, we have fourth degree here and a couple third degrees, but also we're going to be doing a fifth degree. So it's going to be 4 zeros we'll be looking for, and here we'll be looking for 5 zeros. And we're going to do that just by doing synthetic division a little bit more. Yesterday we only had to do it one time, and then we had a quadratic to solve, and we could complete the square or factor. So now we might have to do synthetic division twice to get a quadratic. So more or less the same with a few differences. So let's look at number 20. Okay. Before you jump to doing a rational root theorem on -3, you might notice that it has a variable. So really, since there's no number after here, you don't want to start with rational root theorem. You will might remember that the first step for all solving and all factoring is always looking for a GCF. So here, hopefully that catches your eye that there's an x in every single term, so that means it can be factored out. So we have x to the third minus 3x squared plus x minus 3. And remember, all this equals 0. Alright, so what do we do with this GCF? Well, really, it's x equals 0, and this whole thing equals 0. So from this, we get a nice, easy, freebie root of x equals 0. Now, anytime you have a GCF with a variable, it's going to be a 0 solution or a 0 rational root. So you want to always look for that because it really speeds up the process. Okay, so even if we got like 4x as a GCF, that would still be, divide both sides by 4, that'd still be 0. And even if we got like negative 4x squared as a GCF, well, if you divide by -4, take the square root, x still equals 0. So any GCF that you get at the very beginning with a variable will just be x equals 0 no matter what. Okay. Now let's go ahead and just do the rest of this problem just like we did last night. And you'll hear me say that over and over because we're going to do just a few steps, and it'll eventually turn into one of the same problems that we've already done. Alright, so we have to list all the rational roots. Let's see here. We have -3 here, so that's just going to be plus or minus 1 and plus or minus 3. Alright, you have to go through a few trial and error process. We're just going to go straight to the solution here. So we got 1, -3, 1, -3. And our solution for here is going to be I think positive 3. Yeah, positive 3. Alright, so let's prove that. 3 times 1, add it up, 0. 0 times 3, 0, add it up, get 1. And then as you can see, we get our 0 remainder. Alright, so what does this, that means another root is now 3. So we're still missing 2 more. Remember, we have a fourth degree, so we need 4 total zeros. So we're missing 2 more roots. So we're left with 1x squared plus 0x plus 1. That equals 0. So we're really having to solve x squared plus 1 equals 0. And again, you can use any method you want. Now this is where it's going to really determine how well you do or how much time you spend on every problem and if you're able to finish quizzes and tests. So we don't want to do quadratic formula by default ever, because that's just too much work, and this is a pretty basic problem. And you might look at this and say, well, that looks like a difference of squares. You know, we got x squared, 1 squared, but remember, it has to be a difference. This is a sum. So it doesn't factor as a difference of squares. So before you jump to quadratic formula, just remember, if you don't have a middle term, like if you have the 0x, it's actually quite simple to solve. Just subtract the constant, the number to the other side, and take the square root. So we get just x equals plus or minus square root of 1, which equals I. So our third and fourth roots are just plus and minus I. And we're all done. So this is not a normal problem just because it has a GCF. That doesn't happen too often, where we have a GCF in front and we get a free answer, so to speak, of 0. Right, so the next problem will really show what a typical problem might look like. So on this one, no GCF, and we have to go through the process. We're still keeping it simple though, with a 1 in front, so the rational roots are going to be just the factors of 8. And remember, we're looking for 4 zeros total. Alright, so factors of 8, we're looking at plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So those are the possible rational roots. Alright, so let's begin. Once again, I'm just going to cut to the chase and go the solution route without doing the trial and error. So our first rational solution is going to be -2. Okay, bring down that 1. Simplify it. So we have -2 gives us 8. -2 times 8 gives us -16. And that'll give us a, let's see here, 17. Okay. -2 times 17 is -34. There we get 4. And lastly, we end up with -8. So we know that -2 is our first root. Alright, now here's where it changes. Now, this means, our final answer means x cubed plus x squared. Now normally, from last night, we just got a quadratic here, and we were able to plug it into a formula or complete the square or factor, and then we'd have our last two answers. But here, we can't do that because we have a cubic. So that's what's really different about today, is that you can't just find one root and then go solve a quadratic. We'll have to do synthetic division again, which means continue on our list above and do a trial and error process to find another root. Okay, so this time all we're going to do is just drop another number, and this time we're going to use -4. Okay, drop the 1. Again, you might have to do a trial and error process to finally get these numbers. I'm just going to come out and use the right answers from the beginning. So we'll have -4, 4, -16 will give us 1, and -4 will give us 0. So now we know -4 is our second of 4 roots. Okay. Now we have a quadratic. X squared plus 4x plus 1 equals 0. And now we can solve that and quadratic using any method we want to get our last two roots. Alright, and once again, how do you know what method to use? So unlike the last problem, we have a b term in the middle, so we can't just subtract and take the square root. So that means factoring, completing the square, or quadratic formula. Factoring is the fastest. It doesn't hurt to test. So what two numbers multiply to 1, add to 4. Okay, and it really doesn't exist, so we can't factor. So we might say that this is a 1, that's nice, and that this is even. If that's the case, if you have a 1 here and this is even, makes it a really easy candidate to complete the square. So let's go ahead and do that. If I had like a 7 in front, I would probably do quadratic formula. Or if I had a odd here, I might do quadratic formula. But with those two, it makes it a lot easier just to complete the square. Less work, less chances of mistakes. So set it all up. Half of 4 is 2. Square 4. When you square 2, you get 4. Add that to both sides. You get 3. And then take the square root of both sides. So we get x plus 2 equals plus or minus root 3. And then lastly, add your, subtract your 2 on both sides. So we have x equals negative 2 plus or minus root 3. And those are our last two roots. Negative 2 plus or minus root 3. So altogether I have 4 total. Okay, last one. Now I already went ahead on 22 and made all the rational possible roots in a table. I took all the factors of 40, 1, 2, 4, 5, 8, 10, 20, 40, and all the factors of 6. So again, now we have a factor in front here, so I have to do all the factors of 6. 1, 2, 3, 6. And remember, you want to do the factors of 40 over the factors of 6. So 1 over 1 is 1, 2 over 1 is 2, 1 over 2 is 1/2, 1 over 3 is 1/3, 1 over 6 is 1/6. And remember, all the x's are just repeated. So like, for instance, 4 over 2 equals 2, and I already had that here, so I didn't repeat it, I just put an x. So this makes it quite cumbersome because there are a total of 20 of these with actual numbers in them, and each square has a plus and minus, so there's really a total of 40 possible rational roots, which could be quite cumbersome if you're starting at 1, then -1, 2, then -2, 3, then -3. Might take you an awful long time before you start finding roots. Alright, so we're going to, once again, just come out and say it. The two roots we're going to be working with are -2 and +4/3. Okay, but you might have to go through quite a bit of trial and error to get those two solutions. Okay, so let's go ahead and do the synthetic division. So we have 6, 22, 11, -38, and -40. Okay. And I'm going to go ahead and do the 4/3 first, so we can see what it looks like to do with a fraction. Alright, so remember, a fraction just means multiply by the top and divide by the bottom. So it's like two problems in one. Instead of just multiplying and adding, we'll have to multiply and then divide. And you can multiply then divide, or divide and then multiply. So you can do 4 times 6, which is 24, divided by 3 is 8. Or you can do 6 divided by 3, which is 2, and multiply by 4, which is 8. So whatever way suits you, just use that to get your answers. And with synthetic division, if you have an actual rational root, since this has to come out to +40 to be a root, we can't have any fractions as we go along. So if you're ever doing trial and error, and let's say you tried 5/6, and you notice you have fractions throughout the problem, you can scratch that because it's not going to be one of your solutions. Alright, so here we go. So 4 times 6 divided by 3 is 8. There we go. And we get 30. 4/3 times 30 is going to give us 40. 51. And then 4/3 times 51 is going to be, 51 divided by 3 is 17. 17 times 4 is 68. And we'll get +30. And then 4/3 times 30 again is going to give us 40. So there's our first root is 4/3. And so we got x equals 4/3. Okay, got to find our second root. As I mentioned before, after trial and error, we'll get -2. Let's try -2. Okay, so we get -12, which gives us 18. Don't skip, there we go. -2 times 18 is -36. Gives us, let's see here, 15. Yeah, that's right. And then we get -30. Good. So there is our second root, -2. Now I just abbreviated quite a bit of trial and error into the exact two answers. So for you to get up to this problem on, get up to this point on most of the problems will be a much longer process. Okay, and now we just need to solve the remaining quadratic. So 6x squared plus 18x plus 15, that equals 0. Okay, so you can look at this and you might notice that there is a GCF here. GCF of 3. 3 goes in all of these. Now don't be confused that this isn't a, like before on the first problem where you get an answer of 0, because this is just a number GCF, not a variable. This is like a 15x. Then I could take out an x, or 3x, and then I'd have x equals 0. But since it's just a number, I just want to take it out because it'll make the number smaller. So when I'm completing the square or doing a quadratic formula, I'll have smaller numbers. All right, so let's take a 3 out, divide 3 by all of these. So I'll have 2x squared plus, let's see, 6x. Okay, 15 divided by 3 is 5. And we get 0. Now you have a choice. You can try factoring. Remember, with the coefficient in front, multiply the first and the last. So what two numbers multiply to 10? Add to 6. And you don't get anything that works, I don't believe. Yeah, 2, 3, 1, and 6. Yeah. So factoring doesn't work. So quadratic formula or completing the square. Now with the coefficient in front, when you complete the square, remember you have to divide through by that number. So we'll have some fractions to work with. So if you're opposed to fractions, you might just want to go to quadratic formula. And that's what we'll do. So we'll have -6 plus or minus, let's see here, 6 squared minus 4 times 2 times 5 all over 2 times 2. 2a. Okay. -6 plus or minus root 36. Let's see here, we have 10 times 4 is 40 all over 4. -6 plus or minus -4 over 4. Let's take care of the imaginary part here. So we'll have 2i. Okay, so square root of 4 is 2, and the square root of the negative is I, all over 4. Now you'll notice a 2 goes into all of these. So we can divide all of these by 2. That just cancels out to 1. So remember, only do this if the factor goes into both of these. You have to divide all 3 of these parts. You couldn't just divide the denominator and this real part by 2. You have to divide everything on top. Okay. So we'll get -3i plus or -3 plus or minus I all over 2. And those are our final 2 roots. -3 plus or minus I all over 2. There we go. So I hope this helps. Remember, use these charts to help go through it. you can do your scratch work on another piece of paper, meaning start your list like +1, -1, and once you finally get a synthetic division that gives you a 0, that's when you want to copy it down on your actual homework sheet. But you don't want to fill up your homework sheet with a bunch of misses. Also, remember, if you have a calculator that you can plug this function into, you might easily be able to plug in 1, -1, and remember, you're just trying to see if you plug it in, you get an answer of 0, just like in synthetic division. If you plug it in, you got an answer of 0, right? It would work. So meaning if we plugged in, let's say, one of our roots, -2, we did -2 to the 4th times 6, plus 22 times -2 to the 3rd power, and so on, it would equal 0. So to speak, that f of -2 equals 0. That's how I know it's a root. So if you have a calculator, you can just quickly say plug in 1, plug in 2. You might get to forego all the trial and error, and of course it'd be much faster for you on a test. Okay, remember that's only a $17, $18 investment, and it will save you potentially hours of extra work. So it's probably worth it if you have the time. Okay, so good luck, and we'll see you next week.